Hello guys, welcome back to our channel Apna Tutors. So as you can see, today we are going to start with our new chapter Matrices. This chapter is one of my favorite chapter. Okay, so talking about this chapter involves concepts which are very new to you. Maybe you had never heard about these concepts. So you should try to give attention to this chapter very wisely. Okay, so in by exam perspective, this question, lots of questions are asked from this chapter, and it's part to determinant. Lots of questions are asked from this. So, okay, without wasting time, let's start this chapter. First of all, I have pasted one pamphlet here. After completing the introduction of this chapter, you can refer to this as your short notes. Yeah. So let's start this chapter. Maybe video will be quite long, but you should keep patience. We will have fun in this video. So let's start. So first is definition of the matrix. What is matrix? So a matrix is an ordered rectangular array of numbers or function. The number or function are called the elements or the entries of the matrix. Basically, what is matrix? That matrix is one tabular form involving numbers or some function. I will try to give some simple examples. Suppose I am taking matrix as A, something like this, having element as 1, 2, 2, 1. So this is called matrix. If I give example involving function in the matrix, suppose I am taking sin x. Now I think you are familiar with trigo and all, right? Sin x, then e raised to x, this function is exponential function. Then say linear function x and some quadratic function x square. So this is also matrice. So these are basically the form of the matrices. Now if we if we want to write the matrices in general, we write it as A equals to this way, Aij. What does this Aij means? Aij means element of ith row and jth column. Okay, so matrices involving elements as Aij. So suppose you tell me here what will be A11, that is first row and first column, that is this 1. This is our A11, this is our A12, then this is A21 and this is A22. If you want some very beautiful example of this matrix, you can refer to NCERT. In the starting of the topic matrix, they have gave one beautiful example of real life example of matrix. You can refer to it. Okay, so this is basically the definition of matrix. Now let's move to next topic, order of the matrix. What is order of the matrix? What does order of the matrix means? That it means number of rows and number of columns involved in matrix. Okay, suppose I will try to explain it by example. Suppose I am taking matrix as 1, 2, 2 and 3. Then how many rows are there in this matrix? 1 and 2 rows are there, right? So 2 rows. And how many columns are there in this matrix? 2 columns. So we write order of this matrix at this 2 cross 2. This is called order of A. Order of matrix A. Order of matrix A is 2 cross 2. And suppose one more column I have added one more column, suppose let's say 2 and 3. Then order will change into rows are same only 2, but columns are now 3. So order is 2 cross 3. So you should solve this example and see whether which entry is there in the third row and the second column. That is, they have asked you to find third row, that is A3, and second column, that is A32. Okay, first of all I will explain it here. What will be A32 here? It will be okay, I think here third row is not there. Suppose I am writing third row also, as suppose 1 1 1, then order will change into 3 cross 3. So what will be A32 here? That is third row and second column, that is this element. So A32 is 1. Similarly you need to find it in this example. Okay, so let's move quickly to next topic. Next topic is type of different matrix. Okay, so first matrix is column matrix. You should try to understand it by its name only, then you will not be needed to recall it again and again. So first is column matrix. So what does column means? It should look like one column, right? That is, it's some, if I am writing suppose matrix as this 1 1 1, then this looks like column, right? So column matrix is matrix involving only one column, that is A is of type, if A is of type only one column, that is suppose rows can be anything. So suppose rows are n, so n cross 1. If A is of this is the denotation of the matrix, order of matrix. Okay, if order of matrix A is n cross 1, then A is called column matrix. For column matrix I am writing definition. From the next I will just say it verbally. If order of A is matrix A, in fact, if order of matrix A is n cross 1, then matrix A is column matrix. Okay, you got it, what is column matrix? So next is row matrix. So what is row matrix? Similar as involving only one row. So matrix having order of form type this 1 cross n, that is having only one row but columns are many, then it is called row matrix. Okay, so next is square matrix. Square matrix should be something like this, that is rows, number of rows and number of columns are same, that is A is of type n cross n, number of rows and number of columns are same, then it is called square matrix. Okay, so next three type of matrices are involved only for the square matrix, so that's why I have wrote it in different color. So next is diagonal matrix. Okay, before diagonal matrix I should tell what is diagonal in matrix. So let me write it, diagonal of matrix. Say let matrix be A. What is diagonal of matrix A? So first of all, A should be square matrix. You can talk about diagonal only if A is square matrix. So A should be square matrix, and then element of type A I I are called diagonal, or else let me write collection of element of type AII are called diagonal of, is called diagonal of matrix A. I will give you one simple example by which you will be able to understand it. So suppose I am taking A as some 3 cross 3 matrix, as say 1 2 3, then 2 4 6, then 3 8 12. Then what will be the diagonal of this matrix? As this matrix is square matrix, we can talk about its diagonal. So this 1 4 12 is called diagonal of matrix A. Okay, you got it, what is diagonal of an square matrix A. So now is what is called diagonal matrix. Next task is what is diagonal matrix. By example I will try to explain you. Suppose I am having matrix of this type in which only diagonal element are non-zero, then it is called diagonal matrix. 1, 2, 3, and other element are 0, 0, 0, 0, 0, 0. Then this matrix is called diagonal matrix. That is matrix having only diagonal element as non-zero is called diagonal matrix. Okay, first of all, it should be square matrix. Okay, I forgot to tell you, it should be square matrix. Diagonal matrix is always square matrix. You can talk about diagonal only if it is square. Okay, so suppose I am writing it as like this: 0, 0, 0, 0, 0. So let it be 2 cross 2 only. Still it is square, right? 2 cross 2 only. So can you tell me this is this diagonal matrix or not? Yeah, you should pause it and first think whether it is diagonal matrix or not. Okay, so this will be diagonal matrix. Why? Because what is the definition I told you? That all the non-diagonal elements should be 0, right? That is, only diagonal element can be non-zero. Other than that, all should be 0. Here, other than diagonal elements are 0. Whatever diagonal element can be whatever, it can be 0 also, it can be non-zero also. So this is also diagonal matrix. Okay, so this is the definition of diagonal matrix. Now let's move to scalar matrix. What is scalar matrix? Scalar matrix, scalar matrix is special type of diagonal matrix. Diagonal matrix, that is, if it is diagonal matrix, so for that it should be square matrix also. So I am not writing it separately. Diagonal matrix having all diagonal elements as equal, having all diagonal element as equal is called scalar matrix. Suppose one simple example is of type this: 1, 1, 0, 0. This is square matrix and its diagonal element are same. So this is called scalar matrix. You should recall this example. Okay, I will come into this again. If I am taking suppose B as 2, 0, 0, 2. So it is also scalar matrix with constant in the diagonal element is 2. Okay, so next is identity matrix. Identity matrix. Identity matrix is scalar matrix. Scalar matrix is diagonal matrix and identity matrix is scalar matrix. So identity matrix is also diagonal matrix. So identity matrix is means special type of scalar matrix. Scalar matrix with constant diagonal element as 1. That is the constant element which were involved in scalar matrix. That is the constant element of diagonal is same. That same element is here 1. So suppose I am taking this 1, 0, 0, 1. I had told you to recall this, right? Remember this. So recall this we did in scalar matrix. So this is identity matrix also, this is scalar matrix also, and this is diagonal matrix also. If I give one more example of order 3 cross 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is identity matrix of order 3 cross 3 and this is identity matrix of order 2 cross 2. Okay, so why it is called identity I will tell you further why it is called identity. Okay, so diagonal matrix by name you can remember it, that is only diagonal entries can be non-zero, other than that it should be 0. Scalar matrix, it is scalar time of diagonal matrix. You should try to remember is at this. Square matrix is easy, that is same row same column, then only we can have square form, right? Otherwise it will be rectangle, but we want square, so it should be row and column should be same. Column matrix I had already told you, row matrix I had already told you how to remember it. Okay, so next is zero matrix. As the name suggests, what will be zero matrix? Having all the entry as 0. It is not necessary to be square matrix. Okay, so suppose 0, 0, 0, 0 0 0. So this is 2 cross 3 0 matrix. So this is called 0 matrix. Okay, so let's move to next topic. We are done with type of matrices. So next is when we say that matrices are equal. Okay, first of all, to compare two matrices, its order should be same. Otherwise, how you will compare, right? Then only you can compare it. So first of all, their order should be same, and then if each corresponding element is same, then only you can say that matrix is equal. In what sense I am trying to say that if some element, if I am picking some arbitrary element, it will be of type Aij, that is ith row and jth column. So that should be equals to ith row and jth column of matrix, another matrix which we are comparing. Suppose we are comparing two matrices A and B, then A and B are said to be equal. First of all, their order should be same, that is first condition, their order should be same. And second is that if you pick any element corresponding to that element in other matrix, it should be same. That is if you are picking Aij element from the E matrix, then it should be equals to Bij element of the B matrix. That is ith row and jth column. Ith row and jth column should be same as ith row and jth column of another matrix. Suppose I give you one simple example. I am taking A as 1 1 1 and 1, and B as 1 1 1 and 1. You tell me whether A is equals to B or not. So A is equals to B because first you take this element is equals to this element corresponding this element, that is A11 is equals to B11. This is B11, right? Similarly, A12 is equals to B12, A21 is equals to B21, and A22 is equals to B22. So this is the definition of equal matrice. Now next topic is addition of matrices. So again, for to talk about addition of matrices, their orders should be same. Suppose let A and B be of same order. First I will give you one example, by that I will explain you, then we will go general. We will go to generalize it. So suppose I am taking A as 1 2 2 1 and B as 2 4 4 2. Then what will be A plus B is adding same term from the corresponding element. That is for this add it with this, that is A11 plus B11, that is 1 plus 2 will be 1 plus 2, then 2 plus 4 here, then 2 plus 4 and 1 plus 2, which is same as A11 plus B11, A21 row 2 column 1 plus B21, A12 plus B12 and A22 plus B22. So this is the definition of addition of matrice. That is, if I am having matrice as Aij, this is the general way to write any matrice. Okay, and let's say another matrix B having element as Bij, then A plus B will be matrice having element as Aij plus Bij, that is Aij has been added with Bij, that is called A plus B matrix. Okay, so so A and B should be of same order. Okay, then only you can talk about addition of matrix. So next is properties of matrix addition. So I will do this quickly. These are not asked in exam generally, but still that not asked in exam means the proof is not asked, but yeah, they asked you to verify this property. Okay, so what is first property? Commutative law. Commutative law means that in whatever way you add, it doesn't matter. That is, whether you add B on A or you add A on B, it doesn't matter. that is A plus B is same as B plus A. Okay, so why such happen? So why such happen? That is, suppose if A is written as Aij and B is written as Bij, then A plus B will be, as I told you, what is A plus B? It will be Aij plus Bij, matrix having element as Aij plus Bij. Here A is Aij and B is Bij. A is Aij and B is Bij. Now these all are numbers, right? So they can be interchanged. That is, Aij can be written first. Aij can be written second and Bij can be written first. As numbers are commutative, that in numbers it doesn't matter whether you write Bij first or Aij first. So Bij plus Aij. Now this is by definition of matrix addition. What it is? It is addition of matrix B plus matrix A. What will be matrix B plus matrix A? It will be this side, Bij plus Aij, because element of B is of type Bij and element of A is of type Aij. So it will be B plus A. I had moved very quickly here because these proofs are not asked in exam generally, but still, if you have curiosity, I have told you how to do this. So this is called commutative law. Next is associative law. That is, if you are adding 3 elements, then it doesn't matter which first 2 element you are adding. You can't add directly 3 element, right? First you have to add 2 element, then in that you will add 3rd element. So it doesn't matter whether you are adding A plus B first and then in that you are adding C, or adding B plus C first and in that you are adding C. So it doesn't matter which way you are going. So if you want to see proof, you can just look it into this. I will move to next. So next is existence of additive identity. What does this mean? Existence of additive identity means there involve one matrix, that if you add that matrix in any matrix, there is no change in matrix. Okay, did you got this? What I am trying to say, that there is one matrix which if you add it in any matrix, your matrix doesn't change. That is, if you are having some matrix, say A, then you should find one matrix such that if you add that matrix in A, your A doesn't change. So of course that matrix will be our 0 matrix. Then 0 matrix is called our additive identity. That's what is importance of a 0 matrix. That's why we had studied it separately. We had also studied identity matrix, which will be used in further. Okay, so this is called existence of additive identity. That is, 0 is called our additive identity, because it doesn't matter whether you are adding 0 or not. That is, A plus 0 is same as 0 plus A is same as A. Why A plus 0 is same as 0 plus A? Due to commutative law, or in fact because 0 doesn't matter whether you are adding from right or left. So this is called existence of additive identity. 0 is called additive identity for matrix addition. Next is additive inverse. Additive inverse is, suppose you are having some matrix A, then what would be the matrix by which if you add it in matrix A, you will get your identity matrix, that is 0 matrix. Which matrix you should add in A such that you will get 0 matrix? So of course that matrix should be minus A, right? So minus, suppose you are having matrix A, then minus A matrix is called the additive inverse of your matrix A. It is A plus minus A is same as minus A plus A is equals to 0. Why 0? Because this is our additive identity. So you should remember this, that our additive identity is 0 and additive inverse of any matrix A is minus A. Here notable thing is what you know, that this 0 is for any general matrix. That is, whatever A you take, this 0 will work. But additive inverse is separate for every separate element. Every separate matrix. That is, if you are taking A different, then your additive inverse, that is minus A, will be different. But additive identity will never change. Additive identity is same. That is, 0 is always additive identity. Additive inverse change with element. Okay. So these are called property of addition of matrix. These properties are not asked directly, but they ask questions related to this. They tell you to verify this property, that whether addition is, they will give you one matrix and tell you that verify commutative law of addition, verify associative law of addition. That way they ask in exam generally. Okay, so let's move to quickly next topic, property of scalar multiplication of matrix. Before talking about property of scalar multiplication, let's see what is scalar multiplication of matrix. Here first of all, this scalar means constant. Okay, some constant number, that is suppose I am having any matrix as this 1 2 2 1. Yeah, I like this matrix very much. Okay, so what will be matrix if I multiply whole matrix by 2? So this is called scalar matrix multiplication, scalar multiplication of a matrix. So what you do, you multiply each element by 2. That will be scalar multiplication of A by 2. 2, the 1 into 2 will be 2, 2 into 2 will be 4, 2 into 2 will be 4, and 1 into 2 will be 2. This is called scalar multiplication of A. That is, K times of A is same as the, I had wrote it in reverse way. So what is K times of matrix A? It is matrix with element is K times of A. In the sense, suppose A is equals to having element as Aij, then K times of matrix will be having element as K into Aij. You got it right? This is called scalar multiplication. So it having some properties. So what are the properties? You should try to see matrix as numbers, simple numbers. That what happens if you multiply number by some another number, in two number you are adding, in that you are multiplying same number, then what will happen? In that way, if you will see, it will be easy for you to understand this matrix. Whole chapter you can understand it very easily, because you have seen that in matrix addition also what we are doing, we are adding only two numbers, but change is here many numbers are involved. It is written in tabular form, so every number we are adding one after another. So what will be scalar multiplication of A plus B? So it will be K times of A plus K times of B. Then if we are having two scalar K and L, and if I am multiplying A with K plus L, so it will be same as K into A plus L into A. You can see, right, it is same as number only. That suppose I am having 2 plus 3 into 5. So this is same as 2 into 5 plus 3 into 5. Yeah, so that way you can understand it. So next is, okay, they have given the proof of this. K into A plus B is equals to K A plus KB. You can see this. They have proved both of this. Okay, so let's move to next. If you want to see proof, you can see, but I don't think it is necessary to do. Okay, so next is transpose of matrix. Okay, so this is very new word for you, transpose of a matrix. So what is transpose of a matrix is, suppose I am having some matrix A. Again I will take, okay, now I will take some different, otherwise you will get confused. 1 2 3 4. So what will be transpose of matrix A? First of all, it is denoted by writing T above the matrix. It has some different notations also, like you can write it as E dash also, having many notations, but yeah, NCERT follows maybe this notation. So what is A transpose is that your row get changed into column and column get changed into row. That is, first row will change into first column, that is first column will be 1 into 2, and second row will be changed into second column, that is 3 4. In fact, you can look at it into this way also, that is first column will change it into first row, that is first column will change it into first row, and second column will change it into second row. So this is called transpose of matrix. So it have 4 properties. Which 4 property is there? Let me try to recall that if you are having two matrix A and B, and if you are adding them, first of all, to add them, this would be of same order. If you add them and taking their transpose is same as taking their transpose and adding them. Okay, you should try to remember this as property. In exam, what will they do is they will tell you to verify this property. They will give you two matrix and they will tell you to verify that A plus B transpose is same as A transpose plus B transpose. We will do this in exercise question. Lot of questions will be involving of this type. Now next is A B transpose. Here what will happen, you will be thinking that it will be A transpose into B transpose, but here reverse law happens. What is reverse law? That is, second element will come first and first element will come second. That is, it will be B transpose A transpose. Okay, you should remember it. Okay, if you will do practice, you will have lots of questions involving this and you will then directly recall it. Now next is, if you multiply some scalar by A and then you take transpose, then what will happen? Then that scalar you can take it out common and you can write it as K A transpose. We will do questions involving this property. Okay, so you don't need to think much. And what is fourth property? We are done with scalar. We are done with, fourth property is that if you are taking transpose of matrix and if you are taking again transpose of that matrix, then you will get again back your original matrix. Why? Because first, if you will take first time transpose, then your rows will change into column and column will change into row. And if you are taking again transpose, then again your row will change into column that were original, and your column will change into row that were original. Yeah. So this is the intuition behind this. A transpose of transpose is A. And talking about this property, why it happens so. Okay, so we will do questions in that you will be able to see why this happens, that why this property is pulled. Okay, so let's move to next topic, multiplication of matrix. Okay, maybe I had used it here, multiplication, but I had not covered multiplication. Okay, I will tell you now what is multiplication of two matrix. Okay, sorry for that, I have used it here, but I didn't told you what is matrix multiplication. So I will tell you it now. What is that? So what is matrix multiplication? I will tell you by example, simple example. Suppose A, okay, let me take one example first. A of say 1, 2, 1, 1, 2, 1. So it is of order 2 cross 3. And B, I am taking it of order, taking it of type 1, 2, 1, 1, 2, 1. So its order is 3. In fact, let me take, okay, let it be, or else let me take this one more column. Suppose I am taking it as 0, 0, 0. Then order of this matrix is 3 cross 3. So you can see I have taken columns of A matrix same as row of B matrix. That is the condition required for matrix of multiplication. You can talk about matrix multiplication of two matrix only when there suppose A is of M cross N. Then if you want to talk about A into B, then you should have B as order of N cross some P. Well, P can be anything, it doesn't matter, but column of A should be same as row of B. Then only you can talk about AB. Okay, then only you can talk about AB. Okay, so this is called, okay, so this is the requirement for the matrix multiplication. Let me change the pen. Okay, so what will be A into B? Now our task is to find A into B. That is 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 0, 0, 0. So what you do is you pick first of all one row, that is you pick suppose first row, and you should multiply it with first of all first column. In what sense you should multiply it? You should multiply it like this, that is 1 to 1 into 1 to 1. This will be 1 into 1 plus 2 into 2 plus 1 into 1. 1 into 1 plus 2 into 2 plus 1 into 1. That will be your first element of AB. So it will be 1 into 1, 1 into 1 plus 2 into 2 plus 1 into 1. That will be 2 to 4 plus 5 plus 1, 6. So it will be 6. Then you should pick same row, first row and then second column. So it will be 1 into 1 plus 2 into 2 plus 1 into 1. Again you will get 6. Then same first row and third column. So 1 into 0 plus 0 plus 0, that is 0. Again now first row is done, right? Now you should pick second row. You should multiply it with first column. So it will be 1 into 1, 2 into 2 plus 1 into 1, that is it will be 6. So again if you multiply second row with second column, you will get 6. Then second row with third column, you will get is 0. So you tell me what order you got of AB. Okay, so this is definition of AB. Okay, this is how you multiply two matrix. So what you got the order of matrix AB? You got it as how many row? 2 row. And how many column? 3 columns. So order of matrix AB is 2 cross 3. That is if I write it in general way, if I am having, okay, so first see where is 2 and what is 3. 2 was row of A and 3 was column of B. That what you got the order of AB. So what will be, now you tell me, if I am taking A of order M cross N and B of order N cross P, so what will be the order of A into B? It will be M cross P. That is row of A and column of P. This common will be cancelled. Not cancelled exactly, but yeah, you can try to remember it as that. So this is the concept of matrix. You should have good practice for having matrix multiplication. Yeah, we will do many questions for this also, where you will get some practice. For now, understand it as concept. Okay, so let's move to next topic. Property of the matrix, property of the multiplication. As we did the property of addition, now we are having property of multiplication. Again, okay, first you will see that here there is no commutative. That is, if you are having two matrix, then you may not have AB equals to BA. You may not have this, that AB is not equals to BA. Okay, so your homework is find one simple example where AB is not equals to BA. Okay, it will, if you try to visualize this or in fact understand this concept of order, then only you can find the example where AB is not equals to BA. Okay, so you should try to find this example and try to give it in comments. I will see and I will try to reply you. You should try it, okay, then only you will get something new. So commutative does not hold in general in matrix multiplication. So what properties are holding in multiplication? First is associative. That is, if you are having three matrices A, B, C with order, say order as A of order M cross N, B of order N cross P, and C of order P cross Q, then you can multiply A with B first, then you multiply with C. This will be same as multiplying A with BC. That is, you multiply B with C first, then you multiply A. It doesn't matter. Okay, so notable thing is here, That is, you can multiply A and B. Why? Because here N are same. You can multiply B and C. Why? Because B, P and P order are same. Now you tell me why you can multiply C with AB. Okay, you should pause it and try. Why you can multiply C with AB? So reason is, what will be order of AB? Order of AB will be M cross P. And what is order of C? P cross P. So P is same as P, right? So you can multiply AB with C. Similarly, you can multiply A with BC. You should try why you can multiply A with BC. Okay, so this is property of associativity. Next is property of distributive. That is, distributive is something like this. You are having three matrices A, B and C. Now whether distributive is like this, A into B plus C is same as A into B plus B into C. This is called distributive property. Okay. Here you should see that the order should hold properly in such a way that you can carry out multiplication. Then only you can talk about this distributive property. Next is existence of identity. What was existence of identity in addition? It was zero matrix. That whether you add 0 from the right hand side, left hand side, in whatever way you add 0 in any matrix, you will get what? You will get that matrix, your required matrix again. Suppose, so what will be that in multiplication? If you are having some matrix A, so what matrix you should take such that if you multiply it with A from the right or left, you get A again. So that matrix is our identity matrix. That's why we had studied identity matrix as separately. So A dot I is same as I dot A equals to A. I is called identity matrix. We had already covered it before, that I is our identity matrix. So if you multiply identity matrix to any matrix, you will get that matrix again. Okay, that's why it is called identity matrix. So now you will think that why I haven't wrote about inverse, because you can't talk about inverse of a matrix always. You will not have matrix inverse always. You should have some extra condition, then only you will have inverse of the matrix. Okay, so let's move to next topic. Next is symmetric and skew symmetric. Okay, so now what is symmetric and skew symmetric? So suppose you are having matrix A, when you can say, I am talking about symmetric. Okay, when you say A is symmetric, when you will say A is symmetric, if A transpose is same as A, then only you can say that A is symmetric. That is, if you transpose A and if you are getting that transpose same as A, then you can say that your A is symmetric. One simple example is 1, 2, 2, 1. Now you transpose this, what you will get? You will get it as row will change into column. So again it will be 1, 2, 2, 1. So again you are getting same 1, 2, 2, 1. So here A transpose is same as A. If I name this as A, so A transpose is same as A. So this A is symmetric matrix. Now what is skew symmetric? Now what is skew symmetric? So A is skew symmetric if A transpose equals to minus A. So A transpose is equals to minus A. I will give you one simple example. 0, 1, 2, minus 1, 0. Then this will be minus 2. Okay, this I can, if I write 3, then this will be minus 3 and 0. So if I take it as this as A, then what will be A transpose? You should see it will be 0, 1, 2, minus 1, 0, 3, minus 2, minus 3, 0, which is minus of A. that is 0, minus 1, minus 2. If you multiply, if you take out minus common, or else if you multiply minus with minus, what you will get? What you will get if you will multiply with minus? All elements will be multiplying with minus is same as multiplying with minus 1. Okay, so in what sense I am trying to say? Let me erase it. Okay, so here I can write it as 1, right? Because multiplying with 1 with matrix is same as multiplying every element with 1, so it doesn't change, right? So 1 can be written as minus 1 into minus 1 into this matrix. Suppose I am writing as, this was what, A transpose. Okay, so this will be same as if I am writing minus 1 separately, and if I am taking this minus 1 inside, because K into some matrix is same as matrix of Ka. This will be minus 1 into A transpose. Why? Since Ka is same as K into A matrix. Now you should see that this minus 1 into A transpose will be, if you multiply each element of A transpose by minus 1, you will get A back. So this will be matrix A. So what you got? Minus A transpose is same as minus of A, right? So this A is skew symmetric. What is noticeable thing, you know, in transpose what happens if you take transpose? Okay, first of all, yeah, but for transpose it is not necessary that your matrix should be square matrix. Okay, so for transpose, your diagonal element is always 0. Okay, sorry, for transpose your diagonal will never get changed. Why? Because if you see, 0 are at that place only, because if you change row into column, still 0 is at same place. So diagonal elements are always at same place. But we want, if we want skew symmetric, we want that diagonal element, means that matrix multiplication sign should change. So this 0 should be of, means if we are having, suppose in place of 0, if I am having some A, so if I want this capital A matrix to be skew symmetric, I want this A to be changed into minus A. Why? Because this diagonal element will be at same. Because if you will take transpose, what you will get? You will get A only here, right? But you want that A transpose to be minus A. So you want that A to be minus A. So you want that A to be equals to minus A, which implies that our A should be 0. That is what I am trying to say, that if you are having any matrix is skew symmetric, then its diagonal element will always be 0. Suppose I am having A is skew symmetric, then first of all you can talk about diagonal only if matrix is square matrix. Okay, so A is skew symmetric if then diagonal of A is 0, and you know what is diagonal of A. Okay, so if A is skew symmetric and if A is square matrix, then its diagonal will always be 0. You got it? Yeah, so let's move to next topic. Okay, so some theorems involved. So till how many pages are left? 1, 2, 3, 4. 4 pages are involved. Okay, so let's do this quickly. Theorem 1 says, okay, first of all, you don't need to do proofs for the exam. Generally they don't ask, but it can happen they can ask. So that's why I will explain you. Also, I just love to prove the theorems. In higher studies, if you are taking mathematics, then surely you will have to do lots of theorems and their proofs. Okay, so still for that you should have some habit from now only, that how you should prove theorems. So okay, so what does this theorem tells? For any square matrix A, A is a square matrix with real number entries, then A plus A dash is symmetric matrix and A minus A dash is skew symmetric matrix. Okay, I think I forgot one thing to tell you, that you can talk about symmetric and skew symmetric only if matrix is square matrix, right? Then only you can compare two matrices, right? That A is equals to A transpose is equals to A, then only you can compare. So to say that A is symmetric or skew symmetric, A should be square matrix. That is the condition. Sorry, I forgot to tell you that this condition is necessary first. Okay, then you can say, right, A is skew symmetric, then diagonal of A equals to 0, because now our A is square matrix. I forgot that condition, that's why I was confused. That I was knowing this property, that this hold, but I was getting stuck somewhere, that why I can always talk about diagonal. Now it is clear, because you can talk about symmetric and skew symmetric only if your matrix is square. Okay, so what this theorem tells, for any square matrix A with real entries, A plus A dash is symmetric matrix and A minus A dash is a skew symmetric matrix. So let's prove it quickly. We have to prove A plus A dash is, A dash means transpose. Okay, A transpose. So in NCERT they are using notation of transpose as A dash. So we need to prove A plus A transpose to be symmetric and A minus A dash to be skew symmetric. So first of all, let name this matrix, that let B equals to A, let A plus A dash equals to B and C equals to A minus A dash. Then we have to prove A plus A dash to be symmetric, that is we have to prove B is symmetric, because B is equals to that, right? So for that, what we do, that we need to show that B is symmetric. When we will say B is symmetric, if we are getting B transpose equals to B. This next part we will do further. So we need to show B transpose equals to B. So you tell me what will be B transpose. B transpose will be transpose of A plus, okay, let me change the transpose sign as dash. Wherever I have used T previously, you should write it as dash, okay, because in NCERT they have wrote dash, not T. So A plus dash whole transpose, because this is B, right? So you tell me what will be the transpose of this. You should use the property of transpose. If I am taking this as matrix A and this as matrix B, and if I am taking A plus B transpose, it should be A transpose plus B transpose, that is it will be A transpose plus B transpose, that is A transpose transpose. Now you tell me what is A transpose transpose. It is again, why this hold, because A plus B transpose is same as A transpose plus B transpose. Now A transpose transpose, this is called sin sign. You should use this whenever you want to give reason of something, and you should always give reason whenever you are writing something. This is the rule of mathematics. You can't move further without giving the reason. That whatever you are writing, you should have some reason, then only you can say about that. Okay, so now A transpose of transpose will be A, right? Because we have studied this property. A transpose of transpose is A. Now we know addition is commutative. So A transpose plus A will be same as A plus A transpose. Why? Because addition or plus is commutative. Now what is A plus A transpose? It was B. So we got a required thing that B equals to B transpose. So this will implies that B is symmetric. That is our A plus A transpose is symmetric. Now it's your homework to see why C is skew symmetric. Why C is skew symmetric? If you are not getting, please mention it in comment. In next video I will try to do it, because if I will do it here it will take some time, because it's already very huge video. So you should try it first. It's very easy. It's very similar to this. Here also you will have to use this property, then this property, but here you will have to use one extra property, that is K A transpose is same as K A transpose. Okay, that only property you need to use it. Okay, so let's move to next. Okay, again one theorem is there, that any square matrix can be expressed as the sum of symmetric and a skew symmetric matrix. Here I will use this theorem 1. Okay, what was theorem 1? That if A is symmetric if A is square matrix, then A plus A dash is symmetric and A minus A dash is skew symmetric. Okay, so suppose I am having any matrix, square matrix, let A be any square matrix, then I need to write A as the sum of symmetric and skew symmetric. Okay, here I will use one trick. I can write A as 1 by 2 A. This you will get it by your experience. You can write A as half of this plus half of A minus A dash. Why? Because A by 2 plus A by 2 will be A, and this will be cancelled out. A dash by 2 minus A dash by 2 will be 0. Okay, did you got it? Okay, now this part is symmetric. You should write it in words. Okay, A plus A dash is symmetric and this is skew symmetric by theorem 1. You should write it like that. So you had wrote A as, okay, so now if A is symmetric, then what will Ka will be symmetric or not? Why? Because what will be Ka transpose? It will be K into A transpose, and A transpose is A. So you got Ka transpose is same as K into A. So if your A is symmetric, then you will have Ka as also symmetric. So you got Ka transpose as same as Ka. So here our A plus A dash is symmetric. So you will have 1 by 2 into A plus A dash is also symmetric. Similarly, if you are having A as skew symmetric, then what will be Ka transpose? It will be K into A transpose and A transpose is skew symmetric, so it will be minus of Ka. A transpose will be same as minus A. So you got Ka transpose as minus Ka. That shows that our Ka is skew symmetric when A is skew symmetric. So as here our A minus A dash is skew symmetric, 1 by 2 into A minus A dash will be skew symmetric by this property. You should write it in the way I had wrote this theorem. Okay, you should write it in same way. But rather than proof of this theorem, what is more important, here, that you way to write any matrix as sum of symmetric and skew symmetric. This is very important by exam perspective. I am telling you, there will be one question of this property, that you need to find symmetric part and skew symmetric part of any square matrix. Okay, so you should remember this. We will do question related to this, but proof of this is like this. You should not go so much deep in proof. It will be not asked in your exams, but still you should see it. If your luck is not good, they can ask to. Okay, so let's move to next topic, invertible matrix. Okay, these topics are not of that much importance by exam perspective, but still let's do it. What is invertible matrix? Any square matrix A is said to be invertible. A is invertible if there exists B matrix such that A into B is same as B into A, as same as identity matrix. If you are able to find some matrix B such that this property is holding, we did this in addition, that we can always find inverse of any matrix A in perspective of addition, that minus A will be that element. If you add it from right or behind, you will get identity element. That identity element was zero element or zero matrix. Here our identity matrix, identity element is identity matrix. So that A is invertible, but here matrix is not always invertible. So A is invertible, that you say A is invertible if that matrix, if there exists some matrix B for which this property is holding, that if you multiply B from right side or multiplying B from left side, you are getting the identity matrix. Then you say that your A is invertible and this B is called inverse of matrix A. Okay, now there is one theorem we have to show, that uniqueness of inverse, that is inverse of square matrix, if it is exist, it don't always exist, it may exist or it may not exist. So if it exists, then it is unique. So let's prove it very quickly. So there is one trick to prove whenever this uniqueness involves, there is one trick to show it. So suppose first of all let A be square matrix, which is we want that its inverse to exist. So suppose let A be square matrix such that its inverse exists, such that its inverse exists. Say inverse of matrix A B B. Okay, so they are saying that it, suppose we have to show it is unique. So suppose A is square matrix and suppose its inverse exists, but we have to show it is unique. So suppose we are taking let me erase this. Okay, let A be square matrix such that its inverse is exists. Now I am telling that rather than, we have to show that it is unique, right? So rather than showing unique, we will show in opposite direction, that we will take two matrix, then we will show that the two matrix will be always equal, right? That is, we will take two matrix which are inverse of A, then we will show that the two matrix are equal. That means we are getting unique. This is the way to show uniqueness. Whenever you have asked to show uniqueness, you can use this method. So let B and C be inverse of A. That is, what does this mean? Now you tell me, what does this mean? B and C be inverse of A. So what was the definition of inverse of A? That whether you multiply B from B and C from right or left, you should get identity matrix. Also, as C is also inverse, you should have A into C should be same as C into A as identity matrix. Now we have to show B is equals to C. Okay, so if I take B, can I write B as B into identity matrix? As we know, there is identity existence of identity, which is identity matrix, which if you multiply from right or left, it doesn't matter, you will get that matrix again. That is, whether you multiply B from I into B from right or left, you will get B only. So I am writing B is equals to B into I. Why? Existence of, since existence of identity. Okay, you got it? Identity. Now B into, now our identity is from, if I am writing from here, what is our I? I is C into, or else A into C. A into C. Now if I use associative law of matrix multiplication, it will be B into A into C. Why? associative law of matrix multiplication. Now from here, what is B into A? It is I into C. Now I into C will be C, right? Why? Because again, existence of identity. Like you feel it, existence of identity. So we got B is equals to C. We had taken B and C to be 2 inverse of A, but what we got, that B is equals to C. So it is unique that whenever you are taking 2 inverse, they are same only. So there is only one unique inverse of A. That is, whenever you are having square matrix and if its inverse is exists, then it will be unique. You can't have another inverse. So that is this theorem. So let's move to next what is that? Again we are having one theorem, but I am not now doing the proof of this theorem. If you want proof, you can refer NCERT, and still if you are not getting, mention it in comment. I will surely do it for you. I will make one separate small video for proof of this theorem. So what this theorem tells, that if you should remember this theorem as property, it will be used many times in the questions, and they will ask you to verify this, that if A and B are invertible matrix of same order, then AB whole inverse is same as B inverse A inverse. I think you had seen something like this earlier also. What was that? It was of transpose, that A B transpose is same as B transpose A transpose. Reverse law hold here, right? Same reverse law hold in inverse also, that A B whole inverse is same as B inverse A inverse. That is what this theorem is. Okay, so that's it for the content of this chapter. Still something is there for you, some important topics for the exam perspective. Let's see. Okay, so some important topics for the boards. That first is verifying property of addition and multiplication. We did properties of addition and multiplication, right? Associative, commutative, distributive was there for multiplication. Yeah, we did several property. They will give you some examples and they will tell you to verify this property. They will tell you some separate property that verify commutative of addition, or they will tell you associative of multiplication. Verify that. You need to verify that. They will ask various questions related to this. They can ask in MCQ also. They can ask in big questions also. Another is they can play with property of transpose of matrix. I had told you 4 property of transpose of matrix, right? They can play it with that. They can have questions involving these properties. Okay, this can be asked in MCQs. And one important topic and most important topic for the big questions is representing matrix as sum of symmetric and skew symmetric matrix. I had told you how to represent it. We will do many questions related to that in exercise. So this is very important. These 3 topics are very important for the exam perspective. So this all for today. We had covered the content of the chapter 3 matrices, introduction of the matrices. Hope so you liked it. If you have any query, you can reach out to me through comment section. I will surely reply you. And other than that, from the next video we will start exercise questions. So till that, have a good day. Please subscribe.